Okay, students, so let's take a look at point-slope form. So we're going to talk about this form of a linear equation, and also we'll talk a little bit about how to find slope. So here's an example of a slope, ski slope. Here's my son, Owen. It's my daughter, Margot. It's me taking the picture. So if we're on this point here, and we're going to ski down this slope in a straight line, if we know the point, the coordinates of our point, and we know the slope that we're going down, so that would be, say, that direction, then we can figure out the straight line. We know the point and kind of the direction we're going in is the slope, so that's the point-slope form. So what is point-slope form? Point-slope form is this equation here, which you should have in your notes already. So it's the point is x1, y1. Remember, those are just a set of coordinates. And the slope is m. So I'm just going to use this to figure out the linear equation. And this is just a much more general form of what you've learned before of the slope-intercept form, y equals mx plus b. That's just simply a specific case. Now if I wanted to find the slope, if I only knew two coordinates, you could do that simply by dividing both sides by the x minus x1, and that gives us m, which is our slope, equals y minus y1 over x minus x1. And that's simply just our change in y over our change in x. These are just two sets of coordinates. Some of you probably remember seeing that as y2 minus y1 and x2 minus x1. This is just the same thing. If it makes it easier for you, you can put little 2's there. And that's just our change in y over change in x. So if I wanted to find the slope from two coordinates, say they didn't give us the slope and we needed, but they gave us two coordinates, you could do that. And I like to stack the coordinates because it kind of shows me the change a little easier. And I'll show you how. So if we have our x and y coordinates and I stack them, our change in x, look, the x is just going from 4 to 5. So that's going up 1, right? If I'm going on the number line. And then the change in y is going from 1 to negative 2. So it's just going down 3. 1, 2, 3. So that's negative 3. Just going down 3. So if you prefer to use the formula, you can do that. So it's just slope equals the change in y, which would just be y minus y1 over the change in x, which is x minus x1. Remember, change is just a difference. So that's all I'm doing is I'm subtracting the two coordinates. So I'm just going to subtract the top number from the bottom number here, and just make sure you're consistent. And again, if you like to use y2 minus y1 and x2 minus x1, that's fine. So here, in this case, what I have, this is my y, this is my x, this is my y1, this is my x1. So I'm just subtracting negative 2 minus 1, 5 minus 4. So that leaves me with negative 2 minus 1, of course, is negative 3. 5 minus 4 is 1. That leaves me with negative 3. So that's how you find slope from 2 points, and I just wanted to draw the connection between point-slope form and that slope formula that we've seen before. So this is just, again, a much more easy form to use because you can use it for many different things. So let's take a look at this example from class. Write the equation of the line that is perpendicular to y equals negative 1/3 x plus 2 and passes through the point 4, 2. So again, this sign, this little symbol here means perpendicular. So if it's perpendicular, that means that the slope has to be the negative reciprocal. If it were parallel, it would be the same slope. Now this is in slope-intercept form, where m is our slope, and we should really call it the slope y-intercept form because this is our y-intercept b. So the y-intercept here, in this case, would be 0, 2. So it's just a plus 2 there. So again, you could use point-slope form And simply the x coordinate in the point slope form would be 0. So it's the same exact type of equation. This is just a much more specific case. So in this case, our slope is negative 1/3. So the perpendicular slope is going to be the negative reciprocal. So what do I have to do? By negative, we have to change the sign. So I'm going to make it positive. And reciprocal, you're just dividing it, or it's going to be the quotient. If you're dividing this, you're going to flip it, right? So it's just 3/1, which is 3. So it's going to be our positive 3 as our slope. Now we can use point slope form, which is y minus y1 equals m times x minus x1. So point is x1, y1, m is slope. We have our point here, and we have our slope here. So y minus 2 equals 3 times x minus 4, right? This is my y1, this is my x1, this is my slope. So I just plugged everything right in there. Now I'm going to distribute the 3 to both of these terms, and that's going to leave me with y minus 2 equals 3x minus 12. And I'm just going to isolate the y because that'll get it into slope-intercept form. So y equals 3x minus 10. So again, slope-intercept form is just a more specific case of the point-slope form. Because what I can do is, if I wanted to make this the same here, what I could do is say, all right, well, I know the y-intercept, the coordinates are going to be 0, negative 10. So I could plug in a 0 right here, and a negative 10 here. So this would be y plus 10. Let's write that down. That would be y plus 10 equals 3 times x minus 0. So that's the same thing. That's just y plus 10 equals 3x. I could subtract 10 from both sides, and I'm back to where I was. So I hope this helps, and please let me know if you have any questions.